Hi, Chewy here in the shop, just doing some cleanup after a successful RoboGames. I think I'll do my thing and do a rundown of the robots and all that stuff. So kind of heading into this season, I was really burnt out from doing other robot things, and I was really looking forward to an event that would just be fun. I realize now it had been 5 years since I built a robot on my own, and I was a little bit rusty, as well as many people were a little bit rusty. So my original idea for the Lazy Bot was to do a meme bot, art bot, show bot, whatever you want to call it, which is going to be a 3-piece set: a lazy boy with the footrest as a lifter, a television that broadcasts its own match, and a floor lamp that would spit fire. Unfortunately, the fire marshal did not see fit to grant fire permit at the location, so there was no fire, no intentional fire anyways. So with that idea off the books, had to come up with something at least interesting for me. So I tried to do a little bit of innovation. So I wanted to try these fancy brushless motors that everybody has been fawning over for the last few years, and it seems to be getting to the point where it just kind of works. So as far as the solutions which I have found that seem to be working and off the shelf, one was the Hyperdrive, which is a rebranded Flip Sky 7070 motor, and ESC 75100 ESC, both branded with the fabulous Hypershock Hyperdrive QR code. Buy their merch. So this was a quote-unquote off-the-shelf system. It is available also with a fancy Bales designed gearbox, which, at least from the specs and the paper, looks really good, and it looks to be about what we want. So a pair of those will run you $1,200 or so. The other competing solution that I have seen that works is the Castle 2028 and the Mamba Monster X2 jumbo size Biggie XL. I don't really remember what they call it, but the new big one. Gary Jin seems to be running that setup to great success, as well as a few others have been trying it. So I think that setup will run you like $1,500 for a pair, with some spares, with the gearbox. So pretty close price-wise, but I went with the Hyperdrive because I'm cheap, and I had gearboxes. So I had these Thompson Micron gearboxes sitting on the shelf. I got them from eBay. They're used. 7-to-1. They take 14mm input on the inside of the bushing, or a, I don't know what that is, 18 or something millimeter. Has a nice clamping hub. Very fancy gearboxes. Pretty heavy, about 7 or 8 pounds. Solid steel. They look a little bit rusty inside, so like I said, well used, eBay. But they seem to have held up fine. I just slapped the wheel right on it, right on the shaft. Harbor Freight pink tire. So on my setup, I extended the shaft out the rear and built this support structure that tied into the mounting plate that then ties into the gearbox. So the shaft ended up being a custom arrangement. It's a weldment with a 14mm steel thing on that end, extra stub shaft for bearing support, and then the 2 holes drilled 180 degrees for the 2 set screws that keep the can attached and transmitting all the torque which, I don't know. That one's a little loose. So those double set screws, that's the only thing transmitting all the torque from this motor can. And on the good one, you can see it's loosened up that much. The stock motors are not much better, so I'm assuming this is going to be an issue in the future, but we'll address that next time. So I'm not really sure I can blame the motor for getting, smacked by a big blade, but there's something got pushed into something, and it really tweaked the motor quite a bit. Okay, here, I've pulled the motor out, so maybe you can get a better look at it. Aluminum mounting plate in front, 1/2 inch. Shaft is 22 millimeters with a standard 6 millimeter keyway. It's the support structure with tie rods and the extended shaft. So this one is in pristine shape, other than the can is maybe a little loose on the shaft. And that's paired to the hypercontroller, each one running its own receiver. It's all mounted on a piece of shock-mounted polycarbonate. It actually did crack over on this side, but again, that was like a direct shot from down below, so I'm not sure I can really blame that. The batteries were something else I was trying different. The batteries were cobalt 24 volt power tool packs, 4 amp hour. I was running 2 in series to get 12S cells, and then 2 of those in parallel to get 8 amp hours. And that seemed to be a pretty good match. I think each one of these packs will put out about 50 amps, so somewhere around 100 amps for the whole system, 50 amps per motor. That's about where it's supposedly current limited. In terms of charging, you just slap them on the chargers. They're a little bit easier to deal with than your regular LiPos. And the cases did take some damage. And if that was just batteries tossed in the big open space in the front there, that would have been a nice LiPo fire. But because those are in plastic cases, they're pretty robust. I had some angle iron in there to support the batteries and block it in. So this is an old bed frame. Bed frame's really pretty brittle. Just tore the welds right off. So I don't think I'll be using that again in combat robots. It's just too brittle for combat. Unlike the mild steel on the robot, which is not brittle at all and just punched right in. Oh, some gnarly gashes there. So I bought some plasticky battery adapters off of Amazon, which certainly make it convenient for connecting to the batteries. Very convenient, but cheap ABS plastic certainly does not hold up to combat. But the contacts here are actually made of, I assume it's copper because it's non-magnetic, but I will probably take these apart and remake them with just some pieces of ultra-high molecular weight polyethylene plastic, something like that, that'll take these metal contacts that are under the tape. Insulation. And those batteries were just held down with some weld nuts. These are the kind of top hat shaped ones. So in terms of construction and welding and such, the welding is really fast. The whole frame was built in about a day. Actually, I finished the robot at 8:30 and then drove to the venue for an hour and got the robot through safety at like 9:30, and it closed at 10. So this was a very last-minute build, and overall I'm fairly happy with how it performed. I have pretty much parts left over that I can try and make a test bed robot and make it run a little better, see if it's just a setting that needs to be dialed with these. Both of the controllers are fine. I guess I'll have to buy a new motor. This one seems pretty well broken. So whatever went through the base plate and up, I think it was up because I was upside down at the time, it bent this structure, and it tweaked the can, which tweaked the custom shaft. See, the end is just a little bent that way. And that in turn tweaked this motor can That's really hard to see. There, okay, there. That's it's supposed to look like that. It's kind of flattened. And it knocked both of those screws out of the stripped threads out. Oh, and the this encoder popped out, and I tried to put it back with a paint pen because I didn't bring CA glue. So all in all, I mean it. Even in this condition, at the end of the match, at the end of the event, it was still running. It was certainly not as responsive as it once was, but it all ran. So that's a good sign. Enough that I'm willing to invest the, what is it, $150 for a new one of these. That's not too bad for a heavyweight robot. So all in all, been an interesting event. So there's a whole electronics board, comes out with 4 screws. It was riding on just these weld nuts. So yeah, I think that's the hit that cracked that poly, and probably took out the motor too. Let's see where it's scuffed off the mill scale. Yeehaw! Yeah, electronics board. Waiachi switch, power light, negative terminal, also held on with zip ties, busted. See, there's the crack. Zip ties, more zip ties, rubber shock mounts. Batteries. Motor like that. If I had to do it again, I would shrink the track width and make it longer. Would drive a little better. More wedgy. Yeah, so let's see what's inside one of these things. Open it up, find out which cells it is. They are. Because I have some of these older Cobalt 1.5 amp hour packs. These are probably 5 or 6 years old. They've got Samsungs in them. 15s. I'm curious to know what's inside these things, if it's name brand-ish or not. Anyway, let's open it up. So I would say the thing that stood out to me with this RoboGames was the widening gap between the scrappy teams and the, I guess you call it, professional teams, and the bringing of multiple robots and spares and it makes it even harder for the normal person to compete. Not quite sure how that future works out. Orange cells. Okay, the thing's still potted. And as far as I know, the thing is still directly connected. I don't know, the old ones even have a fusible link inside. Ah, they are, dun dun dun, high stars. ISR 18650, 2000, INR. Okay, so everybody loves High Star. Same one that I think Harbor Freight's putting in a lot of their batteries. So good to know. I would say one of the other things that stood out to me is how much truly the RoboGames and other events like that are labors of love. Labors of love? Everybody there was there pretty much as a volunteer or a robot enthusiast. You know, everybody, the contestants, the people that took the tickets at the door, the arena safety crew, are the same guys that basically put up the box. Yeah, everybody there wears multiple hats. And separately builds a certain sense of camaraderie. And I have to say, it was very good to see the robot family again this year. And I very much hope that it will happen again. It was great to get back into the shop and do some kind of free-form building, just kind of build, and whatever weight it ended up as, that's what it was. Had a lot of fun doing that. It was really great seeing the robot family, and I hope we get to do it again sometime.